Okay, I've managed to diagnose what my problem was. You may have seen it in the last end of the video, but I had actually made a mistake here. List flatten was never really connected up. It was just going underneath it. So I'm just going to now connect it in, and that'll make this whole structure perform correctly. So I've changed this one slider here so it's applied weight. And if we move it along, we can see how that applied weight causes deflection. And the other thing we could do is look up here at what I've labeled now as our second support, and we can actually move this sideways too. Let me just zoom in here a little bit so you can see the framework and then moving the support. So as I pull that support further and further out, the structure has less and less deflection. And then if I go all the way to the end, we start to see the deflection in the center as a simply supported beam. So we get a nice output there. So I'll do a couple of things here. I'll zoom in on this so you can get hopefully this will give you enough of a screenshot if you're having problems with your wiring that you could trace through some of these issues. Then I'll move this over here. Obviously you could hit pause anytime you want and see all of the connections, the terminology here. And I guess the big shot here is where this list is coming from. Excuse me, this list create the two support points. This one is coming out of all the members, and this one is coming from all of the load points. So we have a list of what would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 right now. Yep. And the bottom is just another formality that you have to go through to get it to function properly. I think it's needed. Let me see if I take the geometry binders out. Yep. If there are no geometry binders, it won't work. I don't know if this needs a color definition. Turns out it doesn't need a color definition. It'll probably still function. Let's see if I change the weight on this. So some of these things are critical. This one actually isn't on the geometry binders. It probably has a default value that it sets to that. So anyway, there's enough screenshot hopefully that if you have troubles you can go through and troubleshoot your own. And last thing before we close off this clip of the video, I'll just grab all of these together and we'll create another node. Maybe I'll leave this one out. This is the one where we adjust the weight, and I'll leave that out. I'll pull all these together and create another group, and this is, we'll call this DynaShape analysis. DynaShape, one word. Okay, so now we have everything we need. I have some geometry by I'm just trying to figure out what I had left here. Oh yeah, this is just really the loads. Top loads. This should actually be into this definition here. You can take the time if you want to go through and expand these. I'll spend a few minutes and then I'll come back. I'll try and clean up all of the nodes and then go through and look at them before we move on to the next section, because I think it's important to have a clean looking workflow desktop. So I'll spend a few minutes cleaning up and then I'll come back. We'll look at the cleaned up version and then we'll move on to the next section. And that is changing our members into compression and tension elements, at least visually by color.